All right, lesson 1, starting with the explore and reason. We're talking about part A. What are some methods for finding the distance between points A and B? Anybody? Counting. Okay. Counting. Do we count A? If I start at A, do I count A as 1? No. What do I treat it as? Treat that as your starting point 0. So remember, we're counting the spaces in between. Okay, that's a common mistake I have. So I have 1, 2, 3, 4, 5, 6, 7, 8. So it is 8 by counting. Did anybody use anything else? Yeah.
The distance formula?
You can use the distance formula. Holy moly, you are way ahead. Is there anything else? I'm not going to show that yet. That's coming Monday. Is there anything else you can do? Mathematically, is there any? What if I gave you like 150 and negative 72? Would you want to count all those? No. Subtract. You would want to subtract them, okay? So what is point B on? 5 minus, what's point A? Negative 3. What happens to those two negatives? You add them, right? So 5 plus 3 is? 8. I want to show you something. What if you did negative 3 minus 5? That gives you negative 8. How? I can't just make it positive. The jail bars, what are those? Absolute value. Okay, we're going to absolute value that. If I absolute value that, what is that? 8. Little refresher here. I want you to write anything I write down, I want you to write down as well. Okay, what does absolute value mean? It is the absolute value of the number. What is the technical definition for that?
Distance from 0.
Distance from 0. Yep, distance away from 0. Okay. One more big thing I want you to write down. Star it. Okay. Is there such thing as negative distance?
No.
Can I have a negative distance? No. Even if I'm going backwards, okay, that's still going to be a positive distance away from something else. Okay, so I want you to write down in star, there's no such thing as a negative distance. I'm going to put or length. Okay, no such thing. Okay, so any number we get throughout this section, it should not be negative. Okay, so remember, if it's negative, you're probably going to have to do the absolute value. Capiche? All right. Part B, it's asking which method of finding the distance is the best. So we used counting and we used subtracting. What's the best?
Subtracting.
Okay, I agree with subtracting. For this case, what was probably the easiest? Counting. Okay, but again, if I gave you 150 and negative 72, would you want to count all those? No. Okay, so again, personal preference, but with bigger numbers, you're going to want to end up subtracting. Okay. Terms here. Vocab, start with the word point. Okay, write the word point, and then I want you to draw this diagram here. Okay, right next to that. So a point is literally what you're thinking in your head. It's just a dot on a piece of paper.
You want it in any certain spot or just on the side?
On the side is fine. Yep. Just a dot on the paper. That P, they just labeled it by point P. Okay, that's just a label there. Next one is a line. Go ahead and write the word line and draw that diagram there. Okay. While you're doing that, what makes a line a line?
A line. If it has no curves.
Has no curves. Okay, what else? Does the line stop?
No.
No. Okay, I want you to circle those arrows for me. Okay, those arrows tell you that it goes infinitely in both directions. Okay, and one more thing I want you to write down with that. Here's the notation that you're going to often see in directions. Okay, it is the letters that make up the line, and then what do you notice is up above them? A line, right? It tells you this is line AB. Okay, and last one on this page is a plane. Okay, whenever I talk about a plane, I'm talking about a surface, not an airplane. Okay. I often use your desks as an example. So right now, the plane of your desk, the top of your desk, do you agree you have a piece of paper on it? Or you should have a piece of paper on it. Okay, that is the plane. Talking about this plane up here, it has points X, Y, and Z on the plane. Okay, if I put a point out here and label it A, is that on the plane? No. Okay, what do you think this M is up here? Is that a point? No. Okay, they're using that as naming the plane. Okay, so they called this plane M as the name. You can notate it as plane M. Don't notate it as that. Next one is a segment. Okay, and then write your diagram. What is the difference between a segment and a line? Yeah. It has endpoints, right? So I want you to exaggerate that. It has a start point and it has an end point. There are no arrows. Okay, so when you notate a segment, okay, same thing. It has the letters and then it has just a line segment at the top, no arrows. Okay. Next one is a ray. Okay, what do you notice about that diagram, the difference between a ray and a line?
It goes on one side and on the other side.
Right, it has a starting point on one side and then goes on and on forever in one direction. Okay, and same thing with the notation. It has the letters that make up the ray and it has a little ray drawn at the top. Okay, so it has a start point, has no end point. Next one that's very similar to that is opposite rays. Okay, what do you think opposite rays are? It's in the name. Rays that go in opposite directions. So, what you notice is I have a ray from T to U. I also have a ray from T to S. Okay, those are opposite rays. Okay, the notation for that is the exact same as it was for the rays. Okay. And the last one, angle, which I want to spend a little bit of time on here. Angle is the last one, and then I'll give you time to go ahead and draw that right there, just as it is. Biggest thing for an angle is I want to talk about the notation, okay, because this is going to be important all throughout the whole year, okay? Make an angle with your hands. I'm going to have you do this a lot, okay? What makes an angle an angle? Okay, it's where two lines meet, okay? So on your paper, I want you to label this point right here. That is the vertex, okay? That is where the angle is created. Okay, so when we talk about the notation over here, they call it angle Q. I'm going to ask you this. Why can I not call it angle P?
Only because the angle isn't at P.
The vertex isn't at P, okay? If it was angle P, it would have to look like this. Okay, so we cannot use angle P. Can I use angle R? No, for the same reason, right? Okay, so it has to be named by that vertex. Okay, I'm going to skip down to that bottom one real quick. Angle 2. Why can I call it angle 2? It's on the inside. It literally named it angle 2 on the inside. Okay, so if there's something on the inside, you can also use that as the name. Okay, last one here is probably the most confusing and misconcepted. Okay, so angle PQR. I always get you in the habit of drawing it out to see the angle. So I'm going to start at P, go to Q, go to R. Okay, you can also name it by that. Can I name it angle RPQ? Why not? Because if I did that, I would have RPQ. Is that the same angle? No. What has to be in the middle? The vertex, right? So write that, circle this. Vertex has to be in the middle. Okay, that vertex point has got to be in the middle. So, quick refresher here. We're talking about the length of AC. How many of you counted? Okay, what'd you get when you counted? Yep, 1, 2, 3. Sorry, 4. It is 4. How many of you subtracted? Liza, what'd you subtract? Negative 3 minus 1 gives you? Negative 4.
Absolute value.
You got to take the absolute value of that to give you positive 4. Did both work? Yes. On example 2 here, it wants you to find JK. What are ways you did that? Anybody? Go for it. Counting. Okay, what'd you get when you counted? 7. Did anyone use subtraction? Claire, what'd you do? 12 minus 5 gives you 7. Could I also done 5 minus 12? Yes, but I would have to do what? Absolute value. Okay. Someone new. What'd you get for KM?
15.
Go for it, Marquise. 15. Did you count or subtract? Counted. Okay. Did anyone subtract? Hazel, what'd you subtract?
25
Perfect. Equals 15. And you could have done the other way also with absolute value. Okay. Okay, so off to the side in your notes on example 3, I want you to write segment addition postulate and then go ahead and draw this diagram here. Right below that. Off to the side. Okay. Let's break these 3 words apart here. What does segment mean? Parts of something, right? Does a segment have infinite or does it have endpoints? Has endpoints. Has a start point and an end point, okay? What's addition mean? Add. Yep, add. Does anyone know what postulate means? Does anyone know what the word formula means?
Yeah.
That's what that means. Yep. Postulate is another word for formula or theorem, okay? In geometry, whenever you hear the word postulate or theorem, okay, you're either going to be given a formula or a fact to use about something, okay? So this is segment addition postulate. Now, looking at this, I want you to challenge yourself in your groups. Try and make an equation that makes sense for this line here. So I'm going to get you started. We have a blank plus blank equals blank. And I'm going to give you the first one. AB. Try and fill the rest in. So on this one, I gave you AB. AB plus, what's the next one? BC equals what together? I just heard a bunch of light bulbs go off. AC. Okay, that is the segment addition postulate that you are going to use from here on out. Okay, what happens here? So, this is where you can put your pencil down for a second. I just want you to follow along. It's not in your notes yet. We're going to do this example together. How many of you in math don't read the directions and you just go straight to solving the problem? A lot of us, right? In geometry, you're going to want to read the directions because the directions have important information. Okay? Collinear. Write the word collinear. It's right here. Write the word collinear. Let's break that word apart here. What does linear mean?
Yes.
What word is in linear? Line. Okay? Line. What does co mean? If I'm talking about a coworker. Partner or together or something, right? So, collinear is points that lie on the same line. If you ever hear the word collinear, okay, I'm telling you that, for example, on this one, F, G, and H are collinear points. They are on the same line. If I drew another line right here, and I put a point here, is X collinear to F, G, and H? No, because they're not on the same line. Okay, if I put X here, is X collinear to them? Yes. Okay, all right. So we are going to read the directions here. It says if GH is 16. So I want us to get in the habit. When it tells us that, I want you to mark your picture like this. Okay, this is not in your notes yet. So it tells us GH is 16. It wants us to find FH. What's FH? The whole thing or a part of it? Whole thing. It wants us to find the whole thing. Now, algebra is going to come into play here. When you have algebra, what are you most likely trying to find to help you solve? You want to find X somehow, right? Are there any ideas as to how we can find X here with the given information that we have? Subtract what?
2
From?
16.
Okay. We need to set something up, right? You're on the right track. What do we know about these two right here? They're equal, right? Okay, because we know 2x plus 2 is GH, and we also know 16 is GH. Okay, so those should be equal. So I can do 2x plus 2 equal to 16. How do we solve? Subtract 2. Yep, and then we divide. So we get x equals 7. Is that my answer? Right, this is very helpful, okay, but we want to find what FH is. In order to find FH, we already know what GH is. What do we need to find? We need to find FG. How can I find FG? Put 7 into X here. I want to talk about something that I see sometimes. Does this turn into 37? No. 3 times 7 minus 1. What's 3 times 7? 21 minus 1? 20. Is that my answer?
For that.
For that part, right? So now, how do I find the whole thing? Add them together. We just use the segment addition postulate, everybody. 20 plus 16 is 36. Okay. Biggest thing I want you to do on these. What did I do right after I read the directions to the problem? What'd you say? Right, and I labeled my picture here, okay? So what I want you to do is I want you to do example 3 with your groups. Here, on part A, it tells us the directions. What is the important piece that it tells us? JL is 25, okay? Some of you are like, well, that wasn't like the example you just did. Yeah, I tricked you a little bit. What do I do if I know the whole thing's 25? How can I relate these to the whole thing?
You can add them together.
Right, because we know, review here, JK plus KL equals the whole thing, okay? So we can do 3N plus 5N minus 7 equals 25. How can I solve this here? Combine like terms. That's also true. Yep, I'm going to combine these first. So I have 8N minus 7 equals 25. How do I solve? Bingo. 8N equals 32. Divide by 8. So we end up getting N equals 4. Is that my answer for part A?
Yeah.
Yep. So usually when you find N, that's pretty helpful, right? How do I find JK if I know what N is?
You put 4 and 3 times 4 equals 12.
Correct. Yep. 3 times 4 equals 12. So that's JK. How do I find KL? Yep, I can put the 4 into here. Let's do that first. I can do 5 times 4 minus 7. 5 times 4 minus 7. Did anybody do it a different way? Did anybody find KL a different way? Is there a different way?
Yeah.
How?
You could just subtract 12 to 25.
Right, if I know that JK is 12, I can take 25 minus 12 also. Did we end up getting the same thing? Yes. Okay, so both of those would have worked. Okay. All right. That goes very similar to this is the angle addition postulate. It works the same exact way. Does anyone know what this orange thing is up here? It's a protractor. I am not going to hand you a protractor. Okay. It's always going to be on the paper. We don't see them that often. Okay. What I want you to get used to, you see how there's like multiple numbers here? Okay, I want you to get used to reading the top numbers so we're all on the same page. Okay, so read the numbers that are on the top. So how we read this, I'm going to ask you this. How many degrees is a straight line? 180, okay? What is the angle measure of ABC? Does anyone know? It is 60. Yep, read that top number that it goes through. So we know this would be 60. What would this side be? It would be 120. You can do 180 minus 60, or if you work backwards, it's that bottom number. But again, I want us to get used to the top number. Okay? So, what I want you to do is I want you to do example 4 in your groups A and B. Okay, do example 4, A and B in your groups. Remember the way you read it? AEC, here's A to E to C. That's the one you want to find. All right, so for that first one on your part A, it wants AEC. Reminder on how to read these. Start at A, go to E, go to C. So we want this angle measure here. What do you guys got?
105.
Yep, because it goes right here. So our answer would be 105. That's your number A, or letter A, sorry. Your next one for part B, it wants angle BED. Sorry, I need to talk about notation here real quick. What does this M mean? Measure. Yep. When you see that M, it just wants the measure. So angle BED is here. BED. Can I just say, oh, it's 130?
No.
Why not?
Because that's measuring from 0.
It didn't start at 0. So what do we have to do here?
Start at B, and you have to subtract.
Yeah. So what we should find is we want to find the value of both of these. Brayden, what did you say for this one?
The answer?
Just this measure right here. on B. What's the measure of B?
Oh, 47.
Yep, I would take 47 or 48. What's the measure for D, Cooper? Yep, go for it. 130. So, very similar to what we did at the beginning. How do I find the distance between the two? Subtract. So, I'm going to take 130 minus 47, which is?
83.
It is 83. Could I have also done 47 minus 130? Yep, but I would have got negative 83. Is there such thing as negative? No. Absolute value. Last thing I want to talk about is angle addition postulate. Last thing you need to write down off to the side of example 4. Angle addition postulate is the same exact thing as segment addition postulate. But what are we working with now? Angles. It works the same exact way. Okay, so here, if you draw that picture, angle CBD plus angle DBA equals what? What's the big angle? CBA. Yep. Or if you wrote ABC, that's okay too. It works the same exact way. Okay, so this angle plus this angle equals the whole angle. Did anyone figure out the error to number 2? Marquise, go for it. Okay. Oh, you mean she counted -1? Okay. Does anybody else notice anything big?
She added instead of subtracting.
That's the biggest thing. Yep. We are never going to add in between there to find the distance. This always needs to be subtraction. Okay. Another thing the other class brought up that I want to talk about is when they start with the absolute value right away, okay, some of us want to change this to a +1 right away. Don't do that. Okay, do the -1. Sorry, this is supposed to be a minus now. -1 minus 5. Okay, don't change it until you get to that 1 number value. Okay, now we can change it. Is 6 correct? Yes. Okay, part 4, number 4. Do we need to read the directions?
Yes.
Yes. MKL, what does it tell you MKL is? 42. And then it tells you JKL is what? 84. This whole thing is 84. How do I find that missing angle? Subtract them. Yep. 84 minus 42 is 42. All right. Reviews. Number 5, WX. What are the 2 methods you can use? Counting and subtracting. What did you probably do on the first one? Counting, because it's not that far, right? What'd you count? 2. Why is it not 3?
Because you don't count the W.
Don't count the starting one. Good. What about WY? Let's check this with subtraction. What's the W? -4. Do I subtract or add? Subtract by 5, and we get -9. What do I have to do to get 9? Good. Number 3, there's no picture. What should you probably do? Draw the picture. Okay, here's A, here's B, here's C, and it told you exactly how to draw it. What else does it tell us? AB is 12, AC is 19. It wants us to find BC. How do I do that? 19 minus 12 equals 7. Last one here. It gives you the picture. Do we read the directions? Always. JML. This angle is 80. KML is 33. How do I find that missing angle? Same thing, right? 80 minus 33 is 47. I'm going to ask you this. If it gave you this angle and it told me this is 15 and this is 45, what would you do to find the whole thing? Add them together.